Alright, ladies and gentlemen of YouTube, here is our reboot plan. Oh, and I wanted to make one thing here. This thing, that I called it aluminum. It's not. It's stainless steel. I didn't even know they made such a thing. I bought it a long time ago and only used probably about as much as I used in that piece there from it. It was like 4 feet long is what I'm trying to get at. But it's lightweight stainless steel. It's not like heavy aluminum. I tried bending it into that little square, and it was like, oh wow, that's like considerably tougher than like any aluminum I've ever dealt with. Is what I'm trying to get at. And then I went back and looked at it. It was stainless steel. But what I was going to say is I went through the scrap pile and I found this little jujube. I had one that had like a 3/4 inch pipe coming out of the top, but the disc here was like way bigger, and I don't got enough moxie to drill through that. Is what I'm trying to get at. That's real stainless steel. This will not deform. It's the same thing that the ugly Iron Man's made out of. And this is the inner oxygen container for the lock system. Is this little dude right here? That's like the holy grail of the deal. And the burner should be able to. I'm not going to let the copper come in contact with the burner, because even that got distorted. Is what I'm trying to get at. I thought they were fine. They weren't. They were pretty tore up on the bottom. You can see where they're like burnt off or whatever. It got pretty warm in there, so I'm gonna raise them up where the copper doesn't come in contact with the element. It'll cut its efficiency just a tiny bit, but not bad with the forced air. I'm going to get actually three, but I'll use one at a time until I know how much pressure I need. The fans produce 125 CFM, but at what pressure, I don't know. And I'll just stack them together, and they'll fit right inside that little deal. I'll just buffer it out with like fiberglass insulation or whatever to keep the blowback, the air from blowing back. Everything should be here. I ordered the PID controller, the relays, the everything, the breakers, all of it is what I'm trying to get at. It should be here. On the 6th. I was drawing a blank on the date, but it should be here on the 6th. And then we'll get this rebuilt. That's where we're at. But we're going to use the top section of this. I'll just split it with a parting tool, and just use the top section. I'll remove probably just 3/4 of an inch up, ½ inch. Whatever the fitting is, I'll measure that and get a copper fitting that sleeves over the top. Then it necks down to the same 3/4 inch, and I'll just encroach the pipes as close as I can to that heavy metal. And it shouldn't deform, it shouldn't nothing. I mean, it should be really good. And the bad part is, for any of y'all that like follow what I do and kind of mimic it, you're not going to be able to find these unless you go to a locks dealer, like a liquid oxygen dealer, and you can't ask for them because of the terrorist crap, is what I'm trying to get at. You got to become friends with the guy first, then he has to offer them to you because he can't sell them to the scrapyard. And some of them even have liquid oxygen in them, so you got to be careful, because that in itself is like dealing with a bomb. I bought maybe a dozen of these things. I only have a few left. I got more of the guts than I do the actual whole pieces. But handy, oh wow. You can repurpose that stainless steel for a million different things. Like I said, I was going to cut this one off. If the height is too much, I may take about inch off the bottom of the rim here, or take an inch out of the tank. And I'm going to make a riser that'll lift that's kind of wonky, but if you see how the bend is back here, that 1-inch ring, I'll just neck it down, and it'll hold this up. And that's the problem. That's what I was using that nut for, is to balance that. And I was going to grab a like stainless steel tool or something like that and replace it, and I just forgot to. That's what it came down to. And that was the problem with the deal. And it would have been easier, because I went for a little extension bar that I had like a bunch of them little dudes. But the two ears are to the back with the element, or with the plug-in part, and only one goes forward. So I needed something else, and then I forgot. My bad. 2 truck wrecks, 2 tiny Category 4 truck wrecks is all it takes to be your next memory victim. But this should work like exceedingly well. And like I said, I got the PID controller, the breakers, the relays, the solid state relays. A bunch more than I really wanted to spend. Some new elements to torture. I should have probably ordered a couple more, but I really believe that this is going to fix it. This will be the solve for the sand battery. We won't be melting any more brass, so there won't be any more oxidization. It'll look remainly clear is what I'm trying to get at. This horrendous melted spot in the stainless steel was because of the vortex, the heat vortex that those tubes were making. In the center, it was like incredibly hot. The copper transmits energy better than anything. Stainless steel is really low. That's how come the air duct worked, because it was recirculating its own gas. That's what caused it to thermally run away. When I do it again like this, is I'm going to put a bend in it, and then I'm going to mash that end more oval, and then I'm going to make a hole in the top of this to put the air into. But the bottom will still be that kale wool that's inside this dude here. It'll all rest down on top of it is what I'm trying to get at. A little bit bigger than what I was wanting, but it's not much bigger, than I guess if I put it down alongside of it, it's not much bigger than the plate, maybe about an inch in reality. It's not much bigger diameter. So it should work is what I'm trying to get at. It does as big as it is, it limits how much sand can sit on top of it. The first time I did it without the steel. That caused it to thermally saturate way too quick. It only lasted hours, a few hours. These elements that I had, I'd tested the same element in a bowl with sand in it to hold it, so it couldn't dump over. But open air for days, and it never failed. And I run it through the battery. I run it day and night, days, and it never failed. So it's not the nichrome wire, it's the saturation temperature. Fix that, we can fix the problem. And what I'm going to do with the PID controller is the servo fans that I'm going to put in here to make the blower aspect of it. If one works, great, I'll only use one, because they're 125 CFM. A lot of air. I don't know the pressure that they can produce. I think like 4,000 RPM. There's math. You could figure out the prop angle and all that kind of stuff. But I'm just going to cheat, and I'll stack it. Just make more than one. Kind of like the idea that I was throwing to any manufacturer back in COVID when we needed respiratory machines, is we have those server fans, tens and millions of them. I don't know how our supply logistics is now, but that was a common off-the-shelf answer, and you could stack like 4 of them and run 2 people off of 4 of those fans. So it should produce a lot of air is what I'm trying to get at. But one should suffice is what I'm trying to get at. And if not, I'll stack it, make it 2, and I'm ordered 3, so we'll figure it out. The other one I was going to put in the box and mount the box on the concrete here with standoffs. And that way it can circulate the air. If it's on, the fans are running, and without the fans, it can't turn the element on underneath the deal, the electric element. They can't. I'm going to use the current for the fan, even though they're only like 5 watts a piece. They're really tiny fans. I'm going to use that current to trigger the relay that powers the element that makes all the stuff happen. Without the fans, no element. Without the element, can't thermally run away. Then we're going to fix that too. Where it gets its air from and all that should be the fix, is what I'm trying to get at. Now we just need a big fuel tank and use the bottom piece. It's the same as the top, but use the bottom piece and then put all the pipes into it, coming up through about a 3-foot fuel tank. That would be commercial. I mean, that you're not talking far from being commercial. And when you figure in the price of a fuel tank delivered is less than like 500, the sodium silicate and the sand is nominal money. The PID controller and all the stuff that I just ordered will build this is $200. It was like 204 or something like that. Now the stainless steel and the copper, whoo, that's different. That's a game changer there. Get to know your local scrapyard. That they would have this 6.0 gauge stainless steel. That's heavy. This is some wickedly heavy stuff, y'all, and it's all the same because it held the oxygen. It was the actual. This is the deal that they would bleed off, and then the bleed off is that would cool this to keep it cold. Pretty unique systems. If you get to ever tear one apart, they're just fun. Just how they work is what I'm saying. It's like it's the reverse of thermodynamic heating. It's the cooling. It really is kind of cool. Okay, I'm going to leave it there, and like I said, we're going to probably replace the pipes or trim them down, but this is going to be taller, so the pipes can be a little bit shorter and still fit. And then eventually get a bigger sand battery. But what I was meaning before is I almost got it and then forgot what I was saying, is the tanks being 500 delivered, all the guts being 200 delivered from Amazon. Put it all together yourself, add the stainless steel and copper. You're not talking $1,000 project, even if you're getting raped on the stainless steel and copper. You're not talking $1,000 project that can use DC solar direct or AC much more efficiently, but to heat like in the hundreds of degrees, like 700 degrees, 785. And if it was induced, it would not break, is what I'm trying. It would get better and not tear up. So, I'm telling you, it's. Did I want to spend any more money? No. But does it work good enough? And did it put the house over the top well enough that I want to keep it going? Is what I'm trying to get. And I got the solar to use. I'm only using 12 of the 24 places on that back rack. For $2,000 more and a $300 inverter, which I already have, I can double what I have for power for $2,000, and not even that's delivered is what I'm trying to get at. Getting them in place would be harder than any of the rest. But I'm happy where I'm at. Until I get more batteries, I don't really need more panels, is what I'm trying to get at. Except for doing like a DC direct kind of. That's what I was meaning by that. Okay, guys, I'm going to leave it there, and we will come back somewhere around the 6th, unless I have some epiphany on what I'm doing, or show you how I got it set up or something like that. But I don't foresee that, and I'll let you all go. All right, talk to you then. Bye.